Good day, everybody. Good day. I hope you're all fine. So in this video, I'm gonna do work energy and power, November 2023, question 5. But now, as you can see, it's a different scenario now. You are not seeing an inclined plane with 2 blocks or 1 block or whatever. Now it's an experiment, but it is the same concept. So let us conduct an experiment to determine how the initial kinetic energy. So this is what EKI given to a trolley affects the distance the trolley moves on a rough horizontal surface. When they saying rough horizontal surface, meaning that is what? Kinetic friction. So a learner pushes a trolley of unknown mass until it reaches point A with kinetic energy EKA. The horizontal distance is traveled by the trolley before it comes to rest, then it is measured. So this is the scenario here. So now the experiment is repeated with the trolley moving on the same horizontal surface but with different initial kinetic energy at point A. So these are the results. So when the trolley travels, when the trolley travel 1.5 meters, the kinetic energy it is what? 6 joules. When it is 3, 12 joules. 4.5, 18 joules. So as you can see, as the kinetic energy, as the distance increases, the kinetic energy also do what? Increases. So that's how it is. So draw a labeled free body diagram showing all the forces acting on the trolley during its motion after passing point A. So now when they are saying after, check something. This is point A, and then now they are saying they want the frictional force after. And remember, we were told that the experiment is repeated on the same rough horizontal surface. So now check something after. Okay, so now this is how the free body diagram will look like. And now you already know that you have the first 2 marks for free. So the first one is what? Mg. The second one is what? Normal force, because you know that on each and every horizontal surface there is normal force. Then our frictional force is gonna go that side. Can you see it? Because now they're saying after. So now basically the trolley is going to the right. So now the frictional force is acting to the left. Can you see it? So now the second one says name the independent variable. Obviously you know that the independent variable it is always what? On the x-axis. So this one is the what? The initial kinetic energy. Okay, yeah, from your life science whatever knowledge. Then state the work energy theorem. The net work done on an object is equal to the object's change in kinetic energy. 2 marks for free. And then now calculate the mass of the trolley if the coefficient of kinetic friction between the wheels of the trolley and the rough horizontal surface is 0.18. So now guys, check something. I want to tell you that whenever you see a question that is telling you that the coefficient of kinetic friction is what, always make sure that you do what? You start finding the kinetic friction. Is it fine? So now this is what you're gonna do. You are going to find the kinetic frictional force. Okay, but now how are we gonna do it? Now we'll have to start using the work energy and power principles now, so that you can find the kinetic frictional force. So now there are many ways, but I'm simply gonna choose this one, which is gonna make you all understand. So we simply have to under this thing WNC. You can say wink, but this is the work done by the non-conservative force, and you know that kinetic friction it is one of the non-conservative force. Okay, so it is simply equals to the change in EK plus the change in potential energy. But since you know that this is a horizontal surface, there is no vertical force or whatever, we do not have the potential energy. So we are simply gonna say EK final minus EK initial, so that you don't waste any time. But now check something. Under WNC, we are simply gonna take the work done by what? By by friction. Can you see what I'm talking about? Because now check something. Under the non-conservative force, we simply have what? The work done by frictional force. Okay, so it is simply equals to this. And then when we are done, we are simply gonna substitute. Since it is work done, it is simply gonna be what? Frictional force delta x cos theta equals to. Now we are simply gonna substitute. What is the kinetic energy final? Now you can choose between this and this and that and whatever, but I'm simply gonna choose 6 and 1,5. You can choose the other points, ne? It doesn't matter. So what is the final one? The final one was what? Was 0. Then the initial what was 6. The reason why I'm saying the final one was 0, it is because they told us that it came to rest after passing point A. Okay, so now it is 0 minus. Now the kinetic joules initially it is what? 6. So it is 6 there. So now here I simply have minus 6. Then here I have F 1,5 cos 180. Can you see what I'm talking about? Because you know that each and every time when you're dealing with frictional force, it is always 180. The theta is always 180. So meaning that here we simply have negative 1,5 F equals to negative 6. Then when you divide both sides by 1,5, it simply means that the frictional force is equals to 4 newtons. Can you see what I'm talking about? Be careful there. So now, since we have found our frictional force, they said they want the mass of the trolley. Now I am allowed to use what? My formula for kinetic frictional force. Fk equals to mu k times n. Now we can go back to Newton's laws and revise. Now, since it is n there, it simply means that we must check the surface. Now it is simply a horizontal surface. No force is acting upon that object, meaning that this is simply times mg. 0,18 6 equals to 0,18 times m, and then here we have 9,8. Okay, so now simply gonna find our answer. What is 0,18 times 9,8? 1,764. Okay, or this 18, 1,764 m, and then 6, and then divided by 6 divided by answer, we get what? 3, wait, we must divide 6 divided by 1,764. Okay, so what are we gonna get here? Oh guys, yo, I made a mistake. This was supposed to be 4. Right, let's see, divide 4 divided by 1,764. Then we simply get our answer is 2,27. So therefore m is equals to 2,27 kg. Can you see it? Made a small mistake there, but sorry. So this is how we get it, guys. You must make sure that you check your statement very carefully. So okay, thank you very much, guys. I hope you enjoyed.